Employee free time. This is a premium hard problem. We are given a list of schedule of employees which represents the working time for each employee. Each employee has a list of non-overlapping intervals and these intervals are in sorted order. Return the list of finite intervals representing common positive length free time for all employees, also in sorted order. Even though we are representing intervals in this form, this is basically an intervals object. Like each intervals object has a start and end, like this. But come to the example. This is the example. This is the first employee. Let's say this employee has two intervals. This is the second employee. This employee has one interval. This employee also has one interval. If we see closely here, from 1 to 2 we have a busy slot, from 1 to 3 we have a busy slot, then 4 to 10 we have a busy slot, but 3 to 4 we don't have any busy slot. So 3 to 4 is a free slot, and then 5 to 6 that is included here. So 3 to 4 is a busy slot, free slot, and then minus infinity to 1, that is basically the minimum interval start time is 1, so minus infinity to 1 is a free slot, but after 10 to infinity also is a free slot, but we are not considering that because that we just want the finite intervals. So let's take these are the intervals. This is for the first employee, this is second, this is third, or you can take 0, first and second index. Now I will take all the events, like here the interval started at 1, ended at 2. So 1 with start, 2 with end, then 5 with start, 6 with end. This way I will just take all the events, start and end events with the event type. Next I will be sorting it. Let's sort it. Like this is 1 start, then again we got 1 start, then 2 end and so on. So just one intuition here, when I'm starting an event, at that point from 1, there will not be any free slot because I'm just starting one event. There can be a free slot when I'm ending that event, right? Here at 2 we are ending one event, at 3 we are ending an event, right? So let's keep one balance variable. Whenever we are starting one event, I'll just increment that balance. Balance is initially 0. I'll just increment the balance, and when I'm ending an event, I'll just decrement the balance. So at any point, if the balance is 0, that means there is a possibility of free slots. If the next event starts, like consider this event, it ended at 3, right? So and the next event started at 4. That means 3 to 4. From 3 to 4, we don't have any busy intervals. So that will be in our solution. But how do we keep track of that? We can have a previous variable. So previous initially can be none, but at each time when I am getting any event, so I can just update the previous variable with that event time. So for this 3 end event, my previous will become 3. So when I will process this event 4 start, that time my previous is 3. But the current event that is starting, it's a start event and it is starting at 4. That means there is a gap between 3 and 4. So that will be my free interval. So what will be the time complexity for this solution? So if there are n interval in total, then there are 2n number of events, right? So the complexity will be 2n log 2n. Now let's try to code that up. So these are the busy intervals and I have to find the free slots, right? So what we can do, we can keep track of the events, right? And I'm just going through each employee schedule and then for each interval in that schedule. So this interval will have a start and end. I will add that in our events, right? Events dot append. This is a tuple I'm taking, that is interval dot start with the type start, and similarly intervals dot end with the type end. Then I'm just sorting the events. It will sort based on the event time. Next, I have to process all the events one after another. Like for event time, event type in events, I have to do some processing. But before that, I have to take few variables as discussed, right? We need a balance variable that is initially z. We need a previous variable that is initially none. And what we will be doing is, if event type is start, we can increase the balance. Else if event type is end, we can decrease the balance, right? And also we have to update the previous pointer. Previous pointer will be max of this current previous and or the event time. If previous is not none, right? Otherwise it will be just be event time. Now how we will calculate if there is a possibility of free slot. If previous is present, right? Before that, if balance is 0, right? If balance is 0, then only there is a possibility of free slot. Also previous should be present. Balance will be 0 when I will be processing the first event, right? But that time previous is none. So balance should be 0, previous should be not none, and also there is one condition: previous not equals to event time, right? Why is it that? Let's say previous is 3, the last event ended at 3, and the current start time is also 3. So then please, you are saying like there is a free slot from 3 to 3, but there is no length of this. There is the length is 0 here, right? So this is not a valid free slot. So if previous is not equals to event time, so then let's take one output variable, output list, where I'll be adding my intervals. Well, output dot append will create one interval. The start time will be the previous event ended at previous, and end time will be this event time, because after this event time, at this event time, some other busy interval is starting. So the free slot is from previous to end time. So that's it. Let's return the output. Something is wrong. Yes, there's a typo. Yes, this works. Okay, this works. Can we improve the complexity here? So earlier we were just storing all the events like start event, end event separately, but we can just store the intervals directly, right? So let's store all the intervals directly: 1 3 6 7 2 4 2 5 9 12. Then sort the intervals: 1 3 2 4 2 5 6 7 9 12. And I'll use the same technique that I used earlier. We'll just have a previous variable that will keep track of the last event that happened, right? So previous initially is none, and when I'm processing the first event 1 3, previous is none. That means there will not be any free slot. There will be a free slot from minus infinity to this start time, but that we are not considering. We are just considering finite slots, right? So we'll update the previous to 3. That is the end time of this. Next we are processing 2 4, right? So earlier event that ended at 3, and this event is starting at 2. There is no free slot. So we'll just update the previous value, that is 4. How we are updating the previous value? That will be max of this earlier previous and this current end of this value, current end of this interval. Next, we are processing 2, 5. Earlier, previous is 4 and it is starting at 2. No free slots possible. Then we are updating the previous to 5. Next, we are processing 6, 7. The previous is 5, but the current interval is starting at 6. So there is a free slot from 5 to 6 that we are adding in the output. Then we are updating the previous also, that is 7. What is 7? This is basically max of 5 and 7, that is 7. Next we are adding this 9, 12 interval. Previous is 7. That means 7 to 9 there is no busy interval. So 7 to 9 will be in our free interval output. Then also we are updating the previous value, that is max of 7 and 12. So what is the complexity of this solution? If there are n interval in total, it will be, so for sorting it will be n log n. Then we are just going through the intervals, that is order of n. So it is total complexity will be order of n log n. So first we'll just take the busy intervals. Interval dot start, interval dot end, and that is for each employee, and then for all intervals for this employee. Now I'm just flattening the intervals into this busy intervals. Then I am sorting these intervals. Next, I need a previous variable that will be none initially, and basically we need one list for our output. We can call it free intervals. Now I'm just going through all the intervals for I in range length of busy intervals. If previous is not none and previous less than this current interval is what? Busy intervals I dot start, basically that is 0. Busy intervals I, that is the current interval, and the start, right? If previous is less than this start, that means we have some free slots, right? I'll just add it to free intervals. We'll create one interval that will be previous to this start point. Right now we have to update the previous. Previous will be max of previous or the end time of the current interval, that is busy intervals I1. If previous is not none, right? Else it will be the current end time. So that's it. We can just return the free intervals. It works. Let's submit it. So it's 55.91%. It's n log n. Now let's say we are improving it further. So earlier we took all the intervals and sorted it. Then we did this previous comparison and all, and then we updated our output. Question is, can we improve it? So do we need to store all the intervals? Do we need to sort all the intervals? Because it is given that for each employee, this is sorted. The schedules are given in sorted order, right? So what we can do is we can take a heap. We will just take the first interval of all the employees. That is 1, 3, 2, 4, 2, 5. That will initialize our heap with that. We'll do heapify. That will be our initial heap. Here it's already sorted, but it's fine. We'll do heapify. So if there are E employees, let's say, so this size will be E, right? So this heapify will run in order of E. Now we'll just do the same process that we followed earlier with a one step added. So we are processing 1, 3. There is no restart possible. I am updating the previous variable. But one catch here is we just took the first interval for each employee. This is for this zeroth employee. We need to put this one in our heap. So when I am processing this one, I need to keep track of the employee ID, employee index and the interval index. This is for zeroth employee, zeroth index I am processing. So I have to add for zeroth employee first interval, that is 6, 7 that we are adding. Fine, this is gone. Then we are just popping from the heap. Then we are processing 2, 4. We are updating previous. But 2, 4 for this employee, there is no interval left. So we will not add anything to our heap. Next we will process 2, 5. We will update the previous. Done. For 2, 5 you see this is this employee. This employee has one more interval left. We have to put it in our heap. Right, so we'll add it in our heap. Next we'll process this 6, 7. This is the minimum. So this is the main heap, this is the minimum we are getting. Right, so again we see like 5, the previous is 5, the interval is starting at 6. So 5 to 6 there is a free slot that we are adding in our output. Next we're processing 9, 12, we got a free slot from 7 to 9. Similar way. But the improvement here is with the heap. So basically we are not sorting all the intervals. At each moment, the heap size is E, if E is the number of employees. So any push and pop operation will be log of E, right? So, and this how many operations we are doing at max? So we have to do n operations. So complexity here will be order of n log E. And one thing here, E is always less than equals to n. So there are E employees, right? Each employee can have at least one intervals, will have at least one intervals, right? So n will be at least E. If some employee is having multiple intervals, then n will always be greater than E, right? So E is always less than equals to E. So there is some improvement in this. So I'll create a heap, and what we need in that heap, for each employee I'll just take the first interval, and also I need the interval employee index, and also I need the interval index for that employee. So for employee schedule in schedule, or I'll just enumerate it so that I get the employee index, right? So this is index and the employees schedule, and what I want is initially I'm just taking the first interval for each employee. So interval index will be 0. What I need, employee schedule of 0 dot start. Then what I need, then I need the interval index, then I need the employee index, that will be this one I, and then I need the interval index. So this is 0. Basically first we are taking the 0th intervals for each employee. Fine, we got everything. Then we'll just do the heapify. After doing heapify, I will initialize our previous, that will be none, and then let's say I will take one output list where I will add my output variables. Next I'll just go through the heap, like as long as we have elements in the heap, I'll just do heap q dot heap pop heap, and that will return 3 things, like one is interval start, one is employee index, and one is interval index. right? These three things I got. Next, what I'll do, I'll just check if previous is present and previous less than interval start, right? Then we got one free slot. I'll just add it in our output that happened. I'll create one interval that will be start will be the previous and end will be this interval start. Now I have to update my previous. Previous will be max of previous and what will be the previous? The end of this interval, right? But we don't know the end of this interval, but we know the employee index, we know the interval index, so we can just fetch it like this. This will give the employee and then this interval index will give the interval and I need the end of it, right? So if previous is not null, otherwise the end index for this current interval. We got the previous, we updated the previous. Now one thing we have to do here, so we got the current interval for this employee, but we have to check if this employee has any more intervals, right? For this, if we process this employee this interval, then we have to check for the next interval for that employee, that we have to push in our heap. So if interval index less than length of schedule of employee IDs, this is basically for the employee. I am just taking how many intervals it has, -1. If it is less than, if it is length of this one -1, that means we still have one more, at least one more interval left for that employee. So I'll just add it to my heap q dot heap push heap, and what is the employee? This is the employee and interval index will be the next index, right? Interval index plus 1. But we are not just inserting this interval, right? We are putting three things: interval start, employee ID and interval index. Let's simplify this. Next interval is this one, and what I will be putting in this heap is next interval dot start. Then I need the employee index, that is the same employee index, and I need the interval ID, right? So this is interval IDX plus 1. So that's it. I think we are done. Here we can just return our output. So this works. Let's see how fast it is. Seriously. So I can make few improvements here. Here I am checking if previous is not none, and then we are checking for this condition. So if I just don't initialize previous with none, what I can do? I can initialize with the end interval end time of the first interval. What is the first interval? The interval that is at the top of the heap after heapifying, right? How do I get that interval? So heap 0, that is the top of the heap. So what it will return? It will return a employee, that it will return the interval start point. This is the employee ID and this is the interval ID. I need the employee ID, right? Because I want the end of this interval. So how do I get the employee ID? That is 1, right? This will give me the employee index. Next I want the employee, basically like for whole employee, that I will just get from this schedule of this. This will give me the whole list of for that employee, and I need the first index, first interval, right? That will give me this interval, and I just want the end of that. So if I initialize previous with that, and then we don't need this previous is not null check, we can just remove that. Then one more places here also I'm checking if previous is not none, then I'm just doing this, right? I can just remove this check. Let's run this. It's pretty efficient, 91%. It beats 91%.